Hello everyone. In one of our video called bias versus variance trade-off, so I mentioned that by default all tree-based algorithms are overfitted, right? So when you talk about decision trees, it's a tree-based algorithm. Obviously, by default, it is overfitted. So we'll just try to understand, right? So how it is overfitted by default, right? And how we can overcome the overfitting problem in tree-based algorithms, right? So now we are in the Jupyter notebook. So I'm using the diabetics data set, which I already used it for, when we are talking about the logistic regression, right? So we are not doing any data pre-processing, nothing here. We straight away, going for the tree base, going to build the decision tree here. So we are taking X and Y values, right? In X axis, I'm taking other than the outcome. Outcome is my, the dependent variable. In Y, uh, sorry, in x-axis, yeah, in x-axis we are taking all the columns other than outcome. In y-axis we are just taking outcome, right? And we already know this. So x, y, try and split data, we already seen that, right? So now here, this is the new thing for us, right? I'm importing the decision tree classifier. As we talked in decision trees, right? Decision trees can be used for classification and also for the regression problem. So here, we are using classification. So it is called decision tree classifier, right? Under sklearn tree, right? So here I am creating an object, decision tree object, classifier object. I'm storing in dt, and here I'm fitting dt dot fit. So where I'm passing x train and y train. So now I build a decision tree, and in fact I trained my decision tree without any parameters. So what are those parameters will come in sometime, right? So dt is my decision tree object, where the trained model, you can say, right? So now let me see, there is a way, so where you can display or print the tree which we built, right? That's an awesome feature. So these are the packages which we need to use: export graphviz, y dot plus graphviz, right? So I'll put in a description like how to download this graphviz and install all those things, right? Uh, and here, I'm writing a logic, to print the graph. Don't worry about that, this is the common step to print, right? And here our object is dt, right? So now I need to print the dt here. Let me print it. Now obviously it will take time because you need to build a tree and print it out, right? Yeah, did you see this? It is fully grown tree, right? As I told you, so we already discussed, right, the homogeneity and heterogeneity, right, in our initial videos, right? So the tree will stop splitting until it found the pakka homogeneous, right? Homogeneous means I have a single class. If it is a homogeneous, there is no further split. Heterogeneous means we have multiple classes, two classes, yes or no. When you talk about homogeneous, we have either yes or no, right? In this case, either 0 or 1. Until then, it will build the decision tree. Did you see this? It's fully grown. Now I wrote one function where we are printing the accuracy for our train data and test data. Now let me do this. Did you see? Our training score is 1, which is nothing but 100%. We got 100% accuracy in our train data, and our test data, which is unseen data, we got 65% accuracy. We know how to identify the overfitting and underfitting, right? So when you talk about overfitting, the performance will be good on the train data, but the performance in the test data, which is unseen data, will be very bad. Did you see this? Now on the train data we got 100% accuracy, but on the test data we got 65% accuracy. So we can clearly say this particular model is overfitted. Why? Because it is fully grown. What do you mean by fully grown? Fully grown tree, it read all your data. So it try to understand, it try to interpret all your data which is available, right? And that's what the overfitting is, right? So here in this case, it touches all the points, right? The tree is fully grown until it reaches homogeneous, right? So what happens? Obviously, it will be overfitted. right? Now, how can I work on this? So there are two options. One is pruning. The second option is truncating. So when you talk about pruning, pruning is something like you grow a tree fully and then start cutting from bottom. It's bottom up approach. When you talk about truncating, so I'm not growing my tree fully itself. So I'll decide when to stop, right? When in case of pruning, I'm fully growing my tree and then I'm cutting from bottom. When you talk about truncating, I'm just stopping at initial stage itself. Not I'm not allowing my tree to grow fully, right? So so if you ask me, like, truncation is the best option than the pruning. Instead of you grow full tree and then cut it, right? The truncation is the best way to overcome the overfitting in decision trees. Now we'll talk about once the simple parameter called let me show you. It is called where it is. Yeah, the max depth. Max depth is like the depth of this tree, so which we'll see now, right? So I created one more object where decision tree object, where this time I'm passing a parameter called max depth, which I'm saying 3. In our previous case, I didn't pass any parameter, so it is fully grown. Now I'm saying, boss, don't go the till grow the tree till 3 steps. Don't go beyond it. So which we are truncating at initial stage itself, right? So now, yes, yeah, we fit the model. Now, let me, yeah, print this. It is the DT depth, right? Did you see? One, two, three. We have only 3 nodes. The depth of and the last one is the leaves, not nodes, right? The depth of the tree is 3 root node, and it has 2 child nodes, right? So you can see, the Guinea samples, all those things, right? So now what we'll do is we'll test the accuracy for the tree which we grown where the max depth is 3. This is our object, right? dt underscore depth, right? dt underscore depth, dt underscore depth, right? Now let me check the scores. Did you see? This is not overfitted, obviously, right? We have the train data we got 78% and the test data somewhere around 73. Is like the 5 percentage gap. That is still fine. Maybe now what we'll do is we'll try to put 2 here and just run this. So obviously, if you print this, you'll have only 2 nodes. Did you see? Earlier we have 3 nodes. Now we have only 2 nodes. Now we'll test the accuracy. Maybe I'll do it in another cell. Did you see? It's almost same, but there is slight significant, like little bit change. Maybe we'll try to make it 4 and see how it works. Right? And you can visualize your decision tree here. You'll get 4 nodes, right? 1, 2, 3, 4, right? And now let me in the new cell. But this time it's kind of overfitting, right? You see, in the train data I got 81% accuracy, but on the test data I got 70. There's somewhere around 11%, the difference, which is actually huge, right? Maybe I'll put 5 now. You'll understand why we are doing this, many times. Now, did you see we have depth of 5? Now, let me see the difference. Oh, there's a huge difference, right? In case of depth 4, on my train data my accuracy is 81% and the test data is 71. There's 11% difference. When I increase one depth extra, which is from 4 to 5, there is almost 16% difference between my train and test data, which means like my decision tree is slowly overfitting, right? So, which means what we understood, increasing the depth of the tree is leading to overfitting, right? Now, there might be a chance where it is underfitted also, right? So let's say if I say max depth as 1, right? Now let's see what is my accuracy and train and test data. Oh, it is still good. Okay. But yeah, maybe in this case, because of the small data, might be it is good. But actually, right? So if you have only one tree, it won't make any sense, right? So did you see this? How it makes sense, right? So the problem, the challenge here is, what is the best value? What is the best max depth for my given data? Which I don't know, right? See, in our case, we have small data, right? So we may have some thousands of records. But if you go real time, we may have lakhs, millions of records, right? So, I cannot simply, pass each and every value, first write one, test accuracy, then try with 2 on test accuracy. It's not just one parameter we have, right? So we have multiple parameters which we are going to discuss in our next video. But how can I, find the best parameters, right? So max depth is one of the parameter which we need to find, and we have number of leaves we have, right? So there are many parameters in decision tree. As I said, we'll discuss in our next video. So how can I find the best parameter for a given data set? I cannot simply sit and enter different value, try manually. No, it won't work, right? How can I do that? And that's where we are introducing hyperparameter tuning. So what we'll do is, maybe we'll pass different max depth, right? And we'll say, hey, decision tree, try with this different parameters of max depth. We'll pass a list. Hey, max depth value, try 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It will try with all this value and it will give the best out of it, right? What we need to do, we just need to pass. We need not to run each and every time like what we did. First try with 1, 2, 3. No, right? And this is where we are introducing hyperparameter tuning, which we are going to cover in our upcoming videos. So hope you understood, right? So how the decision trees are overfitting, the difference between pruning and pruning and truncation, right? Hyperparameter tuning, all those things, right? So in our next video, so in this video, we just talked about only one parameter called max depth. So in our next video, we talk about the different parameters of, decision trees, right? And we understand the significance of those parameters towards our decision tree, right? And also we'll try to know understand how we can find the best parameter. So we don't know the best parameter of this max depth, right? So there is no thumb rule that it should be 2 or 3. It sort of depends on the data you have, right? So we'll also try to find those values, right? So hope you enjoyed this video. So please don't forget to subscribe to my channel. Thank you.